The study of goal-directedness got warped in some ways by its Aristotelian and Platonic origins. Plato had this notion of a demiurge, a godlike creature designing the universe for a purpose and with its entities inside of it having purposes. Aristotle saw purposes within things. Those two views leave no options. Either purpose is within, as Aristotle says, or purpose is outside, as Plato says. But Plato has a theistic interpretation these days, and therefore it's out of favor, and nobody thinks there's a demiurge out there. So the whole externalist point of view got ditched in favor of an upgraded Aristotelianism, I would call it. That nobody likes Aristotle anymore in biology, so it's internalism with a different name, it's mechanism. And seemingly there's nowhere else to go. Well, essentially we came along and said, look, Plato was right, there is an external cause, it's just not a demiurge, it's something purely physical that we can investigate in empirical terms.
Daniel, in your paper, Elusive but Everywhere, you introduce this fascinating idea of field theory as a sort of middle ground between teleology and mechanism. Could you explain for us, perhaps in simple terms, and then we can dive deeper, what do you mean by field theory?
Field theory is the notion that all the goal-directed things we know in the universe, this is an hypothesis, this is not a conclusion, hypothesis that all the goal-directed things we know in the universe have a common hierarchical structure, a common architecture, and that architecture consists of a little thing inside a big thing. So let me cash that out with an example. I'll pick the sea turtle example from the paper that you read. First, before I do that, I want to just list for you a bunch of goal-directed systems so you and our listeners will know something about what we're talking about. So there's goal-directed systems in biology that consist of, say, birds flying south. That's what they do up here in the northern hemisphere, flying south for the winter. There's a snail crawling up a beach in order to escape the high tide. There's bacteria swimming up food gradients so that they can get greater concentrations of food in their environment. All that's goal-directed. Those are tropisms. Those are they're movements by organisms that accomplish something for the organism. But they have this peculiar quality of being persistent and plastic. So the bird that's flying south for the winter can get interrupted by all manner of things. It can be distracted by something it sees on the ground. It can find a place to rest for the night. It can see another bird of the same species that it wants to interact with in some way. But after it's distracted, it comes back to its original trajectory. That's persistence. The organism goes on a mission, adopts a direction, is deflected somehow, and then comes back to the original path. And that has a lot to do with how we recognize goal-directed systems. Then there's the notion that in physiology, we are homeostatic systems. Your temperature is regulated. Your hormone concentrations are regulated. All these are complex systems for driving your physiology back to some set point with deflections along the way. It's a very persistent system. If your hormone concentration deviates because of something you ate, well, the system is designed to bring it back to a trajectory toward where it's supposed to be. So that's another goal-directed system. Then there's mechanical, human-designed goal-directed systems like self-driving cars and homing torpedoes, where the homing torpedo, let's say, is tracking a target ship using the sound field coming off the target ship. A current comes along, deflecting the homing torpedo off its path, and the homing torpedo corrects. It uses the sound field coming off the target ship to find a trajectory back to where it was headed originally toward the target ship. So all of these systems have this persistent quality to it, and this is not original with me and Gunnar Babcock, my collaborator on this. It's sort of not the defining quality, it's a hallmark of goal-directed systems. So how to account for these weird behaviors? By the way, I haven't mentioned human intentionality yet, because that's a longer story and I'll get to it. How do we account for all these goal-directed behaviors? Field theory says that all of them consist of a small entity, like the homing torpedo, nested within a larger field of some kind. In the case of the homing torpedo, it's the sound field coming off the target ship. I said I'd get back to the sea turtle example. Let me do that one now. Sea turtles, studies have been done on these things in Florida, but probably all over the world as well, leave their natal beach. They crawl down as youngsters into out of their egg across the sand into the water, and they swim out, far out, hundreds of miles out to sea, where they feed and grow and mate and so on. And then eventually the females want to build nests. They want to lay more eggs. What do? They come back to shore, but not just to any shore. They come back to the shore where they were born, to the natal beach. How do they find it? Well, recent studies have shown that they use the Earth's magnetic field. It's just amazing. Some little magnetic field detector in their heads, we don't know what it is able to give them the signature. It recorded the signature of their home beach, and wherever they are in the world, it can record the signature of where they are, and that gives them the directedness they need to go back and find the natal beach. Again, the entity is the sea turtle. The field is the Earth's magnetic field, and it's on account of the animal's immersion being within this larger field that it's able to find the natal beach. So I've given you two examples now, the homing torpedo and, and the sea turtle. They both have the same architecture. Again, the claim of field theory is that all goal-directed systems have this architecture.
When you talk about goal-directedness in nature, you just spoke about the sea turtles navigating across vast oceans. You also talk about, in the paper, you talk about oak trees. What do these diverse examples have in common? And how does field theory help us understand this?
Right. So I can't believe I left out one of the most important goal-directed systems of all, which is not physiology and animal tropisms, but development. Embryo to adult is clearly, it's the original. It's one of the things that drove Aristotle to talk thousands of years ago to talk about goal-directed systems. You start out with an acorn, it sprouts, it grows into an oak tree, and if something happens along the way, which it inevitably does, a dry spell or something like that, or an animal stomps on it, or whatever it is, it resumes its trajectory toward becoming an oak tree. Again, that's the hallmark of goal-directedness. So what's going on within an acorn that resembles in any way the sea turtle or resembles in any way the homing torpedo? Developmental biology tells us that those little cells inside of an acorn are directed. They're directed by fields, what are called morphogenetic fields, that are really just chemical gradients. So somewhere within that acorn, there's a gradient that's telling it, these cells do this, those cells do that. It's giving cells a series of instructions. It's something larger than the cells, right? And acting downwardly on them, just like the magnetic field is acting downwardly on the sea turtle, telling it where to go. All this within the acorn. I'm not saying there are environmental signals. The environment matters for sure, but the directedness that's turning the acorn into the oak tree, that's chemical fields inside the acorn directing cells that are smaller than that field within it.
Gunnar, when you spoke about, when Gunnar and I spoke about your work, we were touching on the fact that you, Mike Levin, Mark Solms are having these fascinating conversations, and I've been enjoying listening to them and watching them. I'm about to speak to Mike Levin and Terence Deacon, so I'm going to have them both on the show together to discuss their similarities and differences. I asked about this, and I'm curious to know your thoughts on this. What are your views on both their work, and how do they align with yours or differ in any way?
So I have to say, it's going to sound odd coming from somebody in my position in this field, that I don't fully understand either of their work enough to comment on it. There's certainly areas of overlap. It's clear that Terence Deacon and Gunnar and I are talking about the same thing. We're both interested in agency, purpose, goal-directedness, and even at a larger scale of abstraction in meaning. Mike Levin is interested in these things too, but there's something with Terence Deacon, I feel like we're operating at cross purposes to each other without disagreeing, if that makes any sense. Our thinking is orthogonal. In the case of Levin, though, he's contributed something that's been just invaluable for Gunnar and me, which is a formalization of the field concept. He talks in various papers about regions of non-local influence. right? Which is a nice formal way of talking about things that are big, non-local, acting downwardly on things that are little inside them. So we had a notion of fields before we read any of Levin. He's come along, and we're very grateful he's formalized it.
How do you feel when you see this happening? When you're watching, I mean, almost it's live. It's literally in front of our faces. You're watching these great breakthroughs come together, and then you come up with this field theory, and you notice that people are coming in with evidence that helps support this. How does that feel for someone who's been a part of this field for such a long time? Mind the pun there.
Feels a little scary. And I say that because anybody who comes up with an idea that claims to be both comprehensive and true, right, which is what field theory claims to be, that's pretty broad, that's pretty sweeping. It takes a special kind of arrogance to come up with something like that. And I have moments like that. But I also have moments where I realize that just about every broad sweeping theory that's been come up with in the history of science and philosophy is wrong. So the odds are, I should say ahead of time, Gunnar and I are probably wrong. It can't be this simple.
Yeah.
Okay, that said, the arrogant side, at least of me and perhaps of Gunnar as well, says that all these lines of evidence converging, there has to be something there. If we're wrong, we're at least interestingly wrong. Right? So yes, it's wonderful to hear Mark Solms is the most recent contributor to this frame of mind that I've got, where he comes up with this notion of consciousness as affective. And in my language, consciousness is a field acting downwardly on cognitive processes.
Yep.
That's just terrific.
Right?
It just fits field theory beautifully.
Yeah, when I spoke to Gunnar, he was saying that when I brought up the fact that Mark is so close to me here in Cape Town, it's so great to see a South African doing such great work. And then he did mention the fact that his work aligns more with yours than it is, and he loves that concept and that idea behind it. How did you guys come to interact? What was that like? What is that conversation like for you?
Historically, you mean, or how does our interaction?
Yes, historically, and when you guys had these group discussions. I'll put a link to that as well for all of those curious.
Yeah. So historically, I had been working on field theory from 2012 through about 2018 in a low-key kind of way. I got some money to hire a postdoc. I found Gunnar, thank God I did. And he has taken those ideas that were percolating along and run with them and taken them in directions I would never have dreamed of taking them. He has a background in philosophy that's, from my perspective, quite enviable. And he's just contributed so much to this that it feels like the story is ours jointly at this point.
When you look at that, and when people think of postdocs, I mean, they don't really see it, but it's literally like having a philosophical or scientific child within the field. And it leaves legacies and steps going beyond you. That must be pretty cool to watch ideas that propagate from you and then embody someone else and then go on its own journey, creating new things.
Yes, it's everything you just said, except when he's wrong, by the way.
I actually did ask him, where do you guys disagree? Do you want to touch on where you guys actually disagree fundamentally? And then I'll move on to the next question about goal-directedness.
Yeah, sure. You have to dig pretty deep to find areas of disagreement between us. The latest one that's actually kind of interesting and that we're going to explore has to do with internal versus external causes of feelings, of affect, of motivations, and so on. My position is that a lot of it is completely internally produced, that an organism just sitting there bored out of its mind will do something, especially a fancy organism like us, will do something that looks to the outside spontaneous, without external cause, right? Sunny summer afternoon, nothing going on. I got to get out of this place. I got to go for a walk. Well, where did I got to go for a walk come from? It feels internally generated. Gunnar wants to come along and say, look, for all this stuff that feels internally generated, you're going to find external causes of some kind, external triggers of some kind, perhaps historically. In the end, I don't think we're going to disagree on much, but there is a difference of emphasis here with me on the internal and him on the external.
I think that's exactly what he touched on when I asked him this question. So
Oh, okay. Sorry to boringly
it's
repeat
clearly
that.
a percolating idea between the two of you. But
Yep.
back to the paper. Um, One of the concepts you introduce is that goal-directed systems exhibit both persistence and plasticity.
Yes.
Can you unpack these two qualities, what they mean, and how do they fit into a broader theory of goal-directedness?
Yeah. So persistence is just returning to a trajectory after deviation. That's the formal statement of it. The example that we use is the sea turtle one typically, but there are a gazillion other examples like body temperature can deviate because it's very hot outside. Let's say your temperature goes up. The result is all these cooling systems kick in and you cool down again, or you turn on the AC as the case may be, and you cool down again. And the system is persistent in the sense that it returns to its stable intended state, and the sea turtle returns to a trajectory towards its natal beach. Plasticity is related to persistence, and it has to do with flexibility of starting point. So the homing torpedo can start pretty much anywhere within the sound field of the target ship and still find a trajectory toward the target ship. And your temperature can start too low or too high and still find a trajectory toward the target temperature. So plasticity is indifference to starting point, and persistence is returning to a trajectory. Footnote to add to both of those: nothing is infinitely plastic. You can't just drop the homing torpedo anywhere in the ocean and expect it to find the target ship. It has limits. And same with persistence. These goal-directed systems don't recover from all perturbations. The sea turtle carried off course by an enormous current may never find its way to the natal beach. Even though the Earth's magnetic field is everywhere, it could end up in the wrong hemisphere and misinterpret the magnetic field. So there's no guarantees built into any of this. Important last thing to add in answer to your question: persistence and plasticity have, for certain philosophers in the 20th century, been used as part of the definition of goal-directedness. Gunnar and I are not defining anything. We are not defining goal-directedness, certainly not in terms of persistence and plasticity. We're saying these are signature qualities of goal-directed. It's how we recognize them. And what is our definition of goal-directedness? Well, we're going to stall off coming up with one until goal-directed systems are better understood. I don't think we should rush to definition when we don't fully understand what it is we're talking about.
You critique the dominant mechanistic models of goal-directed behavior. How do these models fall short, and how does field theory offer a more complete explanation?
This is a tricky question because everything hinges on what you mean by mechanism. So there's a definition of mechanism out there that's normally attributed to the philosopher Craver, I've forgotten his first name, which says that mechanism is the activity of the parts within something that account for its behavior, with within being the operative word from our perspective. Mechanism is always inside the thing in question. So our approach is non-mechanistic in the sense that we say, yes, sure, mechanisms matter. What's going on inside the head of the sea turtle matters a lot. But it's not enough. It doesn't give direction. It doesn't tell the sea turtle which way to go. You need the Earth's magnetic field, or that mechanism will do nothing. So mechanism is not enough. You need the external field as well, is what we're saying. There are others who come along and say, well, this magnetic field acting on head of sea turtle or on brain of sea turtle, that's mechanistic. And there is an understanding of mechanism which puts pretty much everything that's within the realm of science in the category of mechanism. We are not invoking any spookiness here. There are no ghosts in the machine or anything like that. We're hardcore empiricists, both of us. And in that sense, yes, our theory is mechanistic, but not in the narrow sense of appealing only to the workings of parts inside.
Some of the questions I have might overlap a little, but I think it's still a good way to explore this concept a little further. Field theory seems to offer a unifying framework that could tie together everything, let's say from physics to biology. Could you maybe give us some insight into how your theory might help connect the life sciences with the physical sciences?
In a very straightforward way that many biologists don't like. So in our view, this architecture I've described of little thing guided by a big thing outside of it applies to physical systems as well. If you take a steel ball bearing, and put it at the lip of a bowl and release it, it'll roll around inside the ball back and forth, eventually finding a spot in the middle at the bottom, guided by what? The field of gravity, right? There's no mystery what's going on here. Is that goal-directed or not? Well, most of biology and most philosophers of biology saying, no, that isn't what we mean by goal-directed. It's too boring, too simple, too uninteresting a system. It doesn't have the signature qualities of goal-directed systems like sea turtles and bacteria finding food and so on have. Our answer to that is yes, the ball in the bowl, on account of having an external field guiding a small entity within it, will probably count in the end as goal-directed, important footnote, boringly so. It's the most boring goal-directed system you can imagine, with no internal structure to the ball bearing. At least I didn't specify any. The field is completely understood since Isaac Newton. It's the gravity field. The bowl, we think anyway, we completely understand. There's no mystery here. So yeah, it's goal-directed because it has persistence and plasticity. If you reach in and nudge the ball while it's rolling around, it'll resume a course toward the bottom of the bowl. Think about this, by the way. I invite your listeners to really think about this for a moment, how this must have looked pre-Newton. Back in Aristotle's day, the ball in the bowl, what the hell is going on? It keeps going for the bottom. You know nothing about gravity. Right? You weren't raised on physics. You don't have even a 2-year-old's appreciation of modern physics back then. It must have looked pretty mysterious. It's not mysterious to us at all that Aristotle would have considered something like that to have an element of goal-directedness, of purpose to it. And therefore, it makes it sound less absurd when we go ahead and say, yes, this is a boringly goal-directed system, a very simple one.
Within that example, we often build, as Newton says, we're on the shoulders of giants, we're building upon knowledge of everyone else. Do you ever think that that field theory is so obvious and yet hasn't been thought of, and why hasn't this happened?
Yeah. Okay,
Based on all the information we currently have, it makes a lot of sense.
Yeah, I'm glad to hear you say that. So I'm going to be winging it here because we've thought about this and don't have a great answer. We thought about it a little bit and don't have a great answer. Maybe if we thought about it more, we'd have a better one. The study of goal-directedness got, and this is my language, not Gunnar's, warped in some ways by its Aristotelian and Platonic origins. Plato had this notion of a demiurge, a godlike creature designing the universe for a purpose and with its entities inside of it having purposes. Aristotle saw purposes within things. Those two views leave no options. Either purpose is within, as Aristotle says, or purpose is outside, as Plato says. But Plato has a theistic interpretation these days, and therefore it's out of favor, and nobody thinks there's a demiurge out there. So the whole externalist point of view got ditched in favor of an upgraded Aristotelianism, I would call it, that nobody likes Aristotle anymore in biology, so it's internalism with a different name, it's mechanism. And seemingly there's nowhere else to go. Well, essentially we came along and said, look, Plato was right. There is an external cause. It's just not a demiurge. It's something purely physical that we can investigate in empirical terms.
How did Gunnar feel about that? Because I know he's a huge fan of Aristotle.
Yeah. I think he would agree that Aristotle was doing something very sensible, trying to account for purpose, and that he looked in the wrong place inside. And then we wrote a paper, our first paper together actually was on externalism versus internalism. If you read, as Gunnar has, the details of Aristotle's argument, you'll see that he was puzzled by certain cases of apparent external purposefulness. And I think it was, I'm going to get this wrong, apologies, Gunnar. I think it was in eels, in aquatic eels, they seem to form fully, they seem to Aristotle in his day to form fully formed out of nowhere. They just appeared in the mud, right? With no cause, no internal cause internal to the mud, really. They just pop into existence out of the mud. Aristotle inferred that they and a bunch of other things, including all of human artifacts, by the way, may be an exception to his internalism rule. There may be some things with external causes. So Aristotle was enough of a scientist to recognize where his theory was inadequate. We're picking up on his recognition and saying, yes, and those other cases, most of the cases you're talking about, they fit the eel case as well, and the human artifact case as well.
In keeping with this historical theme, you argue that historical and contemporary views on teleology often treat it as binary. And why is it important for us to see teleology as a spectrum rather than a yes or no concept? And what kind of implications does this shift have on our understanding of natural systems?
Yeah, so I'm going to get philosophical beyond my training and beyond what I have any license to be, and say everything in the universe is continuous. Everything. Everything you think is discrete, except for numbers, sorry, I have to put in math in a separate category, and possibly geometry and possibly logic. But all the things we can talk about in empirical terms and do empirical research on, they're all continuous, including number of heads in people, right? There's Siamese twins that make the idea of having one head problematic, all right? So everything varies. The real question to raise is, why did anybody ever think the opposite? For about 2,000 years after Aristotle, biological thinking was dominated by essentialism, the notion that everything has an essence out there, and a two-headed person is in essence a one-headed person. The reality out there is discrete, right? It comes in units, it comes in categories of things. Well, along came Darwin. Actually, Lamarck gets some credit for this too. Recognizing variation, seeing that everything in biology varies, and essentially ditching the whole notion that anything has an essence. Everything's on a spectrum. Now, of course, it's easy to admit in biology. Let's turn to the rest of the universe, right? Are there degrees of planetness when we're talking about planets going around? Yes, it turns out there are. And we have different names for the different degrees of planetness, from, comet to asteroid to moon and so on. All these are things in orbit around something bigger, and we have different names for them. And everybody in astrophysics knows these categories are continuous with each other, and it's a variation in orbit and size and so on. So when you turn to the physical world, at least at the gross scale, physicists too will sign on to the notion that everything is continuous. Why should goal-directedness be any different? That said, I have to throw in a little anecdote that may amuse you and our listeners. Whenever I meet a particle physicist, one of my first questions is the charge on the electron exactly known and invariant among electrons? And I usually get answers, well, yes, out to 17 decimal places or whatever we've measured. Yes, it is. But that wasn't my question. My question is it exactly the same? And according to the physical theory, it is, but that's physical theory, not according to measurement. So this point of view, I was going to say global, it's bigger than that. This universalist point of view that everything varies should extend to electrons. And if it doesn't, then I'm wrong.
Yeah, I think I wrote a comment saying everything comes in degrees, if I'm not mistaken.
Yes.
According to your work. And
yeah, everything. Everything physical comes in degrees.
It seems like field theory bridges this gap between life sciences and physical sciences. But I'm curious, do you think field theory suggests a different way about thinking about the fundamental nature of life?
Depends on different from what. So in one way, what Gunnar and I have come up with is not original at all. It's derivative of what was called in the mid-20th century hierarchy theory, but it goes back before the mid-20th century. And it sounds so straightforward that it's not worth dignifying it in some ways with the word theory. It's the study of nestedness, of things within things and how they influence each other. It's been a sub-theme in all of biology as well as all of physics for a long time, but only in the mid-20th century did people start to focus on it and drill down on it. It was called systems theory back then. Systems theory means something different in molecular biology today, but it was the science of nested things back then. So we're just taking their hierarchy theory notions and applying them in this new context, goal-directedness, and saying, look, we've got an easy answer here. So you asked, what do we change? What changes as a result of our view?
Let's
A re-emphasis on hierarchical thinking, an acknowledgement of what's conventionally called downward causation, big things acting on little things within them. Very few people, even in philosophy of biology these days, don't believe in downward causation. I could name a few, but most are happy with it. What they don't see is its broad application across biology to all biological systems. And there's still this reflex tendency to, when you want to explain, look down, look to mechanism, look to genes, look inside. And then you ask them about hierarchy theory and they'll say, yeah, that's downward causation works too. Right? So we're trying to make hierarchy theory blossom. That's the bigger picture, and what we would like to be one of our big contributions.
Earlier you mentioned touching on this later on, but I think we can get to there now. In discussing human culture and psychology, you suggest that our wants and intentions might be directed by larger fields. Could you elaborate on how this works on a human scale?
Yeah. So. Two kinds of influence going on here. One is the influence of things outside us on our wants and intentions. So you smell the bakery down the street and you want that that pastry, right? Something outside was a causal field acting on your brain, causing you to want something. There's another level, and this is the one where we get at our most speculative. The want for that pastry is itself a field that's acting downwardly on your motor systems, on your speech center, on your cognition, your thought processes, and so on. It's a big global field, we hypothesize, and these other things like motor centers and speech centers are smaller things nested within it. So that very simple case I just described of the bakery making you want a pastry is actually two levels of downward causation there. And the outer part, the smell of the bakery causing you to want something, is not controversial. The inner part is controversial. Neuroscience will have something to say about whether we're right or wrong about this.
The concept of free will often seems at odds with determinism. In your view, does field theory offer a way of reconciling these seemingly opposing ideas? Can we be free while still being deterministic?
So I'm going to try to explain a point of view that Gunnar would be better off explaining this, but I'm going to try and fake my way through it. A point of view that field theory is consistent with, but it's not unique to us, and that's called compatibilism. It's the notion that everything we do and say and think is fully determined by causes at some level of organization, whether it's within or outside of us. Our view of free will says we can be full determinists. We can believe that everything is fully determined and at the same time have a kind of free will, the only kind of free will that matters. And what does free will mean in this context? It means thoughts and speech and action that originate inside of you. They can be fully deterministic, but if they originate inside of you, like me deciding to go for a walk this afternoon because I'm bored, that originates inside of me, and therefore my fully determined action to go for a walk this afternoon is me expressing my freedom. If something outside of me determines, if somebody puts a gun to my head and said, you're going for a walk this afternoon, right? That's an external influence acting downwardly on me, forcing me to go via my wants and intentions, of course, forcing me to go for a walk, and that's not free. So for free will purposes, the boundary is at the edge of your skin. Causes that are outside make you unfree. Causes that are inside make you free. Some people will complain then, well, that isn't what I wanted out of free will. I didn't want to be determined by my wants and intentions or by my biochemistry or anything like that. I want to be really free. To which our response is, the only alternative to determinism is randomness. Are you saying you want your speech, behaviors, and thoughts to be random? Because that's the only other place you've got to go. And of course, nobody says yes to that. So our summary statement is, the kind of freedom that you think you want either is meaningless, non-random, non-caused, right? Or it's random and you don't want that, leaving you with compatibilism. It's fully determined, and just be satisfied with doing what you want. Parentheses, isn't that all you wanted out of free will, is to be able to do what you want?
Yeah, you introduced the idea that we're not merely pawns of external fields. Instead, we're our own desires and intentions are fields in themselves.
Yes, exactly. That's thank you for bringing that up. That's the key here. Our wants and intentions acting downward on our own mental components. That's free will in action. That's it. That's you getting your way, so to speak, which is what everybody wants out of free will.
When talking about free will, life, and this is my favorite topic, of course, since the name of the podcast is Mind Body Solution. What is consciousness to you, Dan?
Well, up until my recent conversations with Mark Solms, I would have said I have no idea what consciousness is. And I had put the whole thing aside because all I want to talk about is affect, which is a field, and cognition and motor stuff, which is within affective fields, and consciousness, I don't know, it's the blackboard on which cognition writes or something like that. Now that I've talked to him about it and read some of his work, I really like the idea that consciousness is itself affective. It's a feeling response to what's going on in cognition. So I'm thinking about an apple. What's my feeling about the apple? That's my consciousness of it. Whatever my feeling about that apple is, that's my consciousness of it. So now I at least have an answer, thank you, Mark, to what is consciousness. It's a field.
I still remember when Mark first started bringing out this, his hidden spring, and looking at the cortical fallacy and focusing on affect, valence, etc. And at first, this wasn't taken very well. A lot of people really shut down this idea of this ancient brain, and they really did treat his work quite poorly initially. But there's been a huge rise since then, since he's been working with Carl Friston, for showing people how there's many ways that Mike Levin, all you guys, there's so many different ways that his theory actually does work. And it's grown in popularity since then. And we actually discussed that, and he said it's been pretty cool to see this change from like complete dismissal to almost complete acceptance. Well, obviously with the outliers here and there.
I didn't know that he was bragging complete acceptance. I love that.
Well, not complete acceptance. That's
I know what you meant, yeah.
But it has been quite strange to see how quickly this has happened. I would say in the last maybe 10 years or so. It's been quite abrupt. Yes, it's a very fascinating theory.
Perhaps a sign that he's right.
I think he mentioned it was, I can't remember who, but it might have been Nagel, who said this young man Mark might be onto something, and he was very pleased. So, high praise.
Yeah. One of the nice things it does, by the way, is it takes intentionality out of the uniquely human realm and puts it not just in great apes, not just in mammals. It puts it perhaps back in plants, where affective fields, no, they don't have feelings. Plants, I'm not in that school that says they have anything I'd want to call feelings. But they do have that oomph that goes with feelings. That what larger fields do to smaller things is give them oomph. And everything alive, and a bunch of not alive things, have that oomph as well. So it primitivizes consciousness, which is just lovely.
Which is great.
It's a continuationist view of biology.
Yeah, it takes us off that pedestal we love to put ourselves on.
Yep.
Yeah. No. So field theory suggests that large-scale neural networks, or wanting fields, direct our cognitive and motor functions.
Yes.
What evidence, if any, do we have to support the existence of these large-scale neural fields in brains?
Yeah, the first answer is none. And that's why I say we're out on a limb here, Gunnar and I, saying the claim being, if field theory is right, if it's universal in explaining goal-directed behavior, if human behavior can be considered goal-directed, that part is uncontroversial, here's what brain structure might look like. It's got to consist of something big with something small nested within it. Now, you quoted us as saying accurately large-scale neural fields, but that's just one possibility. These could be electrical fields. Mike Levin is a big fan of electrical fields of some kind. Fields can consist of solid objects. The bowl is a field that's helping gravity direct the ball toward the bottom. It's a solid object. There may be physical constraints at the level of solidity and liquidity and so on. Concentration gradients of various kinds that are involved here as well. Large-scale neural fields is just one way to talk about it. That said, we're inviting neurobiology to take a look to see if they can find these things. One other thing to say about it is I've delved a little bit into the neuro literature. It's not my field, so anything I say is quite suspect. But I've never read anything about intentionality, wanting, caring, etc., that contradicts what we have to say. If they found a little organ somewhere that was the wanting organ and it was small and didn't broadcast a large field of any kind, then Gunnar and I are in trouble. But they haven't so far as I know, I should say.
There's an interesting tension in the paper around conflicting ones, like wanting to eat a piece of cheesecake, but also knowing it's not healthy. So how does field theory help us understand these intense internal conflicts?
Yeah. And here I'm going to have to take you back to a philosopher, David Hume, who argued that affect is my terminology, not his, wanting, caring, preferring, and so on, is the cause of all conscious behavior. And there's no other possible cause. He's an 18th century philosopher. What did he know about neurobiology? This is an in-principle argument. There's no other possible cause for willful, deliberate behavior. So what does a decision look like in Hume's world? A decision is going to be a conflict between wants. Warring passions is his term. He recognized passions, not wants. Passions, by the way, for him included calm passions. So my wanting to go for a walk this afternoon, it's not a violent emotion of any kind. Would you really call it a passion? He called it a calm passion. And it's one of the motivators that operates within us. There's lots of them. When I'm faced with a piece of cheesecake or 10 pieces of cheesecake and consider that I'd like to eat all of them because it's good, why wouldn't I want more? Why wouldn't I wolf them all down now? Immediately what happens is a bunch of passions come into play. One is just outright desire for the cheesecake, more of it. And then if I stop and think before I guzzle all the cheesecake, other passions come into play because my big forebrain kicks in and starts painting pictures of me lying in the emergency room after a heart attack from clogged arteries from having eaten too much cheesecake in the course of a lifetime. And some affective part of me goes, no, don't do that. And immediately we have a tension set up between one constellation of passions associated with eating the cheesecake and another constellation of passions associated with not eating the cheesecake. And whoever wins, that's what I decide to do. That's my will, is whichever one wins. And as we all know, many of our most important decisions sit on a knife edge, constantly going back and forth between one set of passions and another, with the big forebrain, the calculator, cognition, operating in the background all the time, painting pictures of alternative futures for our affect to react to positively, negatively, adding weight to one decision, taking weight away from another. So this Humean point of view, which is fully consistent with field theory because it puts the passions in the center of the causal picture, this Humean point of view accounts for the most boring decisions of all, including my decision to scratch this slight itch on my face right now, to going for a walk this afternoon, from when do I want to retire, or do I want to retire at all, or who shall I marry, and all these very important questions of great weight that it's just conflicting passions, and it gets very complicated in people. It's less complicated in simpler animals.
We can consider field theory as an emerging idea, relatively new, but you've been working on it for quite some time. What are some of the next steps for research in this theory?
Next steps is to watch over the neurobiology literature to see what they come up, see if anybody takes our challenge and comes up with something either deliberately to test our theory or in pursuit of some other agenda comes up with something that we find of interest. Another is just to do battle. Field theory doesn't have a lot of adherents at the moment. We have a lot of people like you and many of our the readers of our Eon piece that you're quoting from, who listen to it and go, yeah, that sounds right to me. But within academia, people, including us, operate from entrenched positions, and most people are dug into entrenched positions that are at odds with field theory. And our job as academics is to go to not war. That makes it sound too too desperate. To argue with them and try and convince them and convince the next generation that we're on to something. If not that we're right, at least that we're on to something. Also, to stress, and one thing I want to add to this, there's an empirical component to this, which there isn't to much theorizing about goal-directedness and purpose. We want to go out there and explore and have students explore all these goal-directed systems to see first if we're right, but not just in a confirmatory kind of way. McShea and Babcock, you got it sort of right. Here's where you're wrong. Here's where the theory needs to be tweaked. We really want that to happen. So the way forward is to try to bring in empiricists to actually do and that was true of the neurobiologists I mentioned as well, to do the hard empirical work to find out more than we know about how goal-directedness works.
And that's something I love about having this podcast and this channel in general, because I have a series where I have lectures as well, and then I have the podcast, and I call this show Mind Body Solution sort of a bridge between mainstream academia and popular media. I call it Acamedia, just a nice play on words there, but for the most part, I found that since having this, a lot of the professors that have been on the show, people in the past, have looked at the comment section and gotten some ideas from it. So you have a lot of armchair philosophers, some real professors in the comment section who criticize or critique the work, but in such I would say, accurate and precise manner that it's actually informative to the person on the show. So this is becoming quite a great way for people to interact with the content, engage with it, and people you'd never expect, which has been pretty cool.
Can't wait for comments to come in. I love interacting with larger audiences. Just last week, I gave a talk to a retirement group near here in Chapel Hill, North Carolina, and got some of the best questions out of that group, better than most of the questions I get from academics.
Yeah, exactly. And I think that's the best part, is that you just diversify this audience to a point where you get some creative thinkers out there. Are there any kind of experiments that you think might help this theory?
Other than
let's say there's a future undergrad looking to come into a postgraduate situation, what do you think they should focus some of this work on?
Well, it depends on whether you're talking about biology and philosophy, and that's going to turn out to be a problem for our purposes, because in philosophy, this is a natural topic, goal-directedness generally, for a student to take up, but not to take up the empirical side of that. They don't really do that much of that in philosophy. And somebody coming into it from biology is going to get weird looks from their graduate committee when they take up goal-directedness as their topic of interest. So it's tricky to find the right group of students to do that. Still, I think, coming from the biology side, which is the side I would know best, if I could interest a bunch of undergrads in research projects, and we've had a couple who've been really interested, one of whom I have a paper with out in the past few years, if we could get them and also graduate students to do theses on how do goal-directed systems work from a scientific point of view. Forget all our abstruse philosophizing here. Just tell us empirically how they work, and do it not just by investigating how sea turtles do it. You could spend a whole graduate dissertation on sea turtles, and people have, and some of them are brilliant. But pick two disparate systems, sea turtles and bacteria swimming up a food gradient, and investigate empirically what they share and what they don't share as a kind of test case for the larger theory. And if you can do three systems, that's even better.
When when you started out in this field, were there any particular thinkers that come to mind who inspired you and motivated you to branch off in this philosophy and biology?
Yeah, so first, David Hume, whose influence goes back to my undergraduate days. And then I'd have to say a bunch of hierarchy theorists from the late 20th century, starting with Bill Wimsatt and Stan Salty and Herbert Simon. And I'll give some credit to Dan Brooks as well. Feibelman, I've forgotten his first name escapes me at the moment, was a philosopher and I think a literary critic back in the 60s. All these people are hierarchy theorists, and Stuart Kauffman to some degree as well. And I think their critical insight was in seeing that this kind of causation is different. And Hume too saw that this kind of causation, feelings acting on behavior, is different than the way a clock works. So I give lots of credit to them and a couple others that I can't pull to mind right now, but they really are the foundation of all of this.
For anyone trying to understand this work, do you find that there are specific types of, aside from hierarchical theory, do you think there are any types of books or content people should absorb in order to understand this better? What would be a nice bridging a gap between this and your work?
Yeah. So, yeah. Herbert Simon has a nice paper on the architecture of complex systems that's very readable, and it dates back to the 60s sometime, I think. Ernest Nagel has a paper on purpose and function, the name escapes me at the moment, from the 70s. And other than that, everything Bill Wimsatt ever wrote. And most of what Stan Salty ever wrote. Problem is, a lot of what those two have written is not all that accessible to a general audience, and that's what makes me nervous about recommending it.
That's understandable.
Yeah.
Dan, there's when you think about academia and a lot of the thinkers that come and go, many of them are very afraid of teleology and even discussing this concept.
Yeah.
What gave you the bravery to go down this route? Because there's quite a fear when it comes to this in academia.
The fear is justified. It's a field that's associated with ghosts in the machine, with spookiness of some kind. There's a great quote, I could be from J.B.S. Haldane, mid-20th century, is purpose is the mistress that all biologists need but can never fess up to in public. It's there in biology. Everybody knows it's there. And people who talk about purging that kind of thinking and that kind of reasoning from our biological vocabulary are covering up, right? Most of them are. Because they know that there are these bizarrely behaving systems and we need to account for them. So what gives me the nerve? What gives me the nerve is what gives everybody the nerve to talk about these things. You just talk about what's on the table in front of you. So I understand the reluctance to go there because of the checkered history, the spooky history of goal-directedness. But, enough is enough. Let's account for this behavior.
Yeah. Is there anything about field theory and purpose, teleology, goal-directedness in general that you feel we haven't touched on, but you'd like to expand on a bit and perhaps clarify or rectify?
Yeah. The big sticking point is going to be human intentionality, wanting, caring, preferring. There are as many understandings out there, both in the minds of professional psychologists and neurobiologists and so on, about what those things are. There are as many of those as there are among the general public. No consistency of vocabulary, no consistency of usage, no consistency of underlying model. People talking past each other left and right, appearing to disagree like crazy when in fact they're talking about different things. We need to straighten this part of it out. And I don't know how to do that. I don't command the language. I don't command people's usage. So this Gunnar and my work is an attempt to come up with a model, a take-home model that will help organize people's thinking. The trouble is going to come when we start to talk about human intentionality and caring and so forth, because we can't look at a magnetic field in a turtle or a sound field in a homing torpedo. All this is going on inside our heads, and it's a mush there. I want people to try and think in hierarchical terms, as Hume did, and to take affect seriously, take passion seriously, take wanting, caring, preferring seriously. These are not nice add-ons to cognition. They're what make you do every single deliberate thing you do. And my tone of voice is now I'm turning this into a rant. I apologize. But I think fuzzy thinking about human intentionality is the root of a lot of our problems. Gunnar and I are working to fix that. I don't have a lot of optimism about our ability to do it. We're just two people in the maelstrom.
I had two questions I didn't ask because you sort of touched on it, but now that you're bringing this up, one of them was you touched on the idea that our desires and intentions direct our thoughts, speech, and actions. But I wanted to ask if you could expand on this idea of wanting fields in the brain and how they might be related to larger cognitive processes like decision making and problem solving, because I think this will also help expand on this a little more.
Good. So let's take a logic problem, like we did this in 10th grade geometry in my past. How do you prove the sum of the interior angles of a triangle is 180 degrees? It's a problem in logic. Well, if I just start speaking to my laptop right now, which is a supremely logical machine, and say, prove to me, right, that the sum of the interior angles of a triangle is 180 degrees, it will do it, but it won't care to do it. It doesn't want to do it. It doesn't want anything. It's pure mechanism. It's pure cognition, if you will. Let's do a little thought experiment. Let's take my laptop and put it out on the street in front of my office, where buses and cars go by all the time, with the top open so the camera can see the buses and cars coming. And let's gauge its perfectly logical reaction to this oncoming and certain death. All right, when the car runs over it, when the bus runs over it. It has no reaction because it doesn't care. It doesn't want anything. Pure mechanism doesn't have the right hierarchical structure to want anything. Cognition is pure mechanism. Reasoning is pure mechanism. Logic is pure mechanism. And that's why my laptop is so good at it, or my phone, if you will, is so good at it, because these are logic machines. Right? These are language manipulation machines. They're not wanting, caring, preferring machines. This is the big defect in modern artificial intelligence research, is they're going to figure out how intelligence works one day. They've sort of simulated it up till now. One day they're going to figure out how it works, and it's not going to solve the problem of human decision making. Right? You need to solve the problem of caring first, of wanting to solve the problem, of caring that the sum of the interior angles of a triangle is 180, if only to get an A on the test upcoming, right? Because otherwise I'll sit there passively and do nothing.
Do you think that's possible? Do you think that we could do that with some silicone system?
Sure. Hierarchical structure is not complicated. Thermostats inside a house do it, right? You want fancier ones if you're going to simulate cognition, or if you're going to have real cognition, if you're going to have real organisms wanting, caring, preferring, and behaving as a result of those wants, cares, and preferences, and so on. You're going to need complicated fields with complicated mechanisms inside the fields, and so on. But yeah, it should all be doable in principle. I have no problem with that. There's nothing unique to biology or unique to people about that. And I think I said earlier on, plants do it, right? And bacteria do it. So there's no reason we couldn't make machines that do it. Just the current approach to thinking about cognition is mostly, as I understand it, I'm outside my field here, non-hierarchical.
One of the more speculative parts of your theory involves the interplay between different scales of wanting, both internal and external. Can you give us a concrete example of how these various fields, from personal desires to societal influences, might intersect and influence a major life decision?
Yeah. So I'm going to imagine myself an 18-year-old deciding which college to go to. And we can pretty clearly identify the external influences, one's parents, your peer group, the state of the economy, What sort of jobs are out there? All these things, the market for this, that, and the other skill set, right? All these things are external fields acting downwardly on your brain via your senses and language and so on, and affecting your brain, causing it to behave in a goal-directed way. Now comes the question of which college you're going to go to. And it's not the sum total of those external fields. You contribute something, and the you is going to be the set of affective fields that's native to you. The bit of it that's both influenced from above and the bits of it that are not so influenced from above. And you discover that, by golly, there's only one thing I love in this world, and it's drawing. I love drawing. And I know there's no jobs for it out there, and I know my parents don't want me to be an artist, and my friends think it's the stupidest thing in the world and I'll never make a living. But you know what? I'm going to do it. It may be a mistake. I should say to all potential drawing students out there, that it may be a mistake to do that. Maybe you should do drawing in your spare time and be an IT engineer for a living. But I'm just saying there is something to oppose those external fields, and it's you, all right? And it's to give one of the practical sides of this, if there is a practical side, is to give people at key decision moments in their lives some backbone, something to stand up for. You are not just your external influences, you are your internal fields.
When Gunnar spoke, we spoke about this, and I asked him that first question to round off. I also asked him, who are the major influences in the field? I've asked you the same question. If you guys, and field theory, if you had to summarize your work now and apply this to the meaning of life, the universe, and the purpose of the universe, how would it explain this?
So there's purpose in the universe and purpose of the universe. And purpose of the universe, well, from field theory perspective, you have to have a field outside the universe directing the universe, in order for the universe to have a purposeful behavior or existence of some kind. And I can't talk about, and nobody can talk about things outside the universe. So let's put aside the question of purpose of the universe. Purpose in the universe, if field theory is right, arises from these hierarchical relationships. How does that affect meaning, the meaning of life? Well, the meaning of life is the degree to which you are doing what your commanding fields tell you to do. That's what meaning is. So the degree, since my commanding fields are my internal fields mostly, doing what they tell me to do, that's where I'm going to find a meaningful life. But it's not entirely my internal fields. There's external ones too, like my family and loved ones and my society and so on, right? They have a part. There's meaning to be derived from that too. Now comes the question, is there anything bigger than that? Well, there's all of humanity, which is a kind of weak field operating way up here on societies, which are acting on families, which are acting on individuals, right? It's nested fields within fields, and they become more attenuated and weaker as you go further out. The Milky Way galaxy is a field too, but it doesn't much affect the meaning in my life. Right? And I shouldn't really take it into account much when deciding how to live my life. The closer the field is to you, the more it matters to you. So purpose in the universe comes from this nested hierarchical relationships. They matter to you to the extent that they are close to you, immediate, affecting you directly. I don't care about purposes at higher levels much. I care about the ones that are close to me, maybe at the level of humanity, maybe at the level of all life on Earth, and not much beyond that.
Well,
until the aliens show up.
I was just going to say, well, what happens if something changes within our
Yes.
this? But I guess you sort of touched on that. But what would happen if that had to happen, and we had to expand this in a little bit? What would change?
I'm sorry, if what?
If aliens did come, let's say if we did have some sort of an interaction with some sort of microorganism obviously out of this planet, what would happen to our nestedness? Would we slowly branch this out slightly? Would we change this? Do we reconstruct our narrative?
It depends, because if some creature, let's say on Mars, let's say gets into conflict with us or wants to cooperate with us or something like that, that's not quite a hierarchical relationship yet. That's two things of about the same scale interacting with each other. That's two billiard balls bumping into each other. If we go to the next scale and say, look, humans. Unbeknownst to you, there's a whole galactic network out there of societies, and you're part of it, whether you like it or not. There's a United Federation of Planets, or a Klingon Empire, or whatever it is out there. Now we've got a higher level that's going to be acting downwardly on us, and we have to start thinking differently about where our purposes fit into it. That said, my decision to go for a walk this afternoon is still not going to be influenced much by the United Federation of Planets. It's too far removed. On the other hand, at a bigger scale of my life or my lineage or something like that, I'm going to have to be thinking about where that fits in to that bigger scale. Yeah, the theory doesn't say there's no bigger scales. They could drop onto our doorstep at any time.
Well done. It's amazing work, and I look forward to what comes next. Any final words about field theory or this topic in general that you'd like to add?
I'll just add that the Eon piece is our best and latest attempt. What can you just read the title of that?
It's elusive but everywhere.
Yes, okay, and it's in the online magazine Eon, AEON, and it's our best and latest attempt to explain all this to a larger audience. We welcome feedback on it. I think the comment period for Eon is closed, but please send us emails. I love to explain this stuff, defend this stuff, and discover problems with this stuff. So I encourage all listeners to do that.
Yeah, I'll definitely put a link to that. It's elusive but everywhere. A new theory argues that unseen fields guide all goal-directed things in the universe, from falling rocks to voyaging turtles, by Daniel McShea and Gunnar Babcock.
Yeah.
Yeah. Thanks.
This was a lot of fun. Thank you, Tevin. This was terrific. I enjoyed this.
Thank you very much. I enjoy this all the time, and I think you've been a terrific guest. I can't wait to see what you guys come up with, and it was a pleasure to chat to you, Dan.
Likewise.